this is one of the important concept, that is page fault. So what is page fault? Suppose you have a process which has a virtual memory. Okay, you divide the virtual memory into pages. Okay, 5 pages. Okay, and you will map these pages to a main memory. We all know that thing. But what happens if your main memory does not have a space to handle all the pages, all the 5 pages? They can only handle, suppose, the 3 pages. So there are only 3 page frame to map the pages. Okay, suppose the first page map to this page frame, second to this, third to this. So what will happen to these two? These two will be mapped to a page frame that is present in the secondary memory, and these page frame are called swap. So these page frame map will be to the secondary memory. I hope you understand this. So what will happen with this? Suppose your process needs some page. Okay, so what will first it do? It will first go to TLB. Okay, TLB, and that is called TLB hit. But if the TLB miss happen, then what will happen? What will happen? The process will go to page table, and from page table, it know that whether the page frame is present in the primary memory or secondary memory. If it is present in the primary memory, means main memory, then what will happen? The main memory pages will come back to the TLB again, so that next time if the same page frame is required, then TLB hit happen. And if that page is not present in the main memory, then this is called page fault. What is called page fault? Page fault is that condition in which the page frame is not present in the main memory, then page fault happen, and 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 the process come to the secondary memory to get their page frame, that is called swap. And from swap, this page frame move to the main memory, so that next time when these page frame are required by the process, they can directly get by the main memory, do not require again to travel to the secondary memory. But you ask very good question here. How will page table know that this page frame is present in a main memory or a secondary memory? This will know with a extra bit. So you know that page table contain virtual memory and physical memory addresses. So suppose you have page 4 or 5 pages, so you have this type of conditions, mapping condition, you know that. Along with that, page table contain one more bit, that is called present bit. If the present bit is 0, that means the page frame are present in the main memory. But if the bit is 1, that means this page frame is present in the secondary memory. So whenever the process table go to the hit, if hit miss, then it go to the page table, and know that whether the present is 0 or 1. If it is 1, then it go to the secondary memory with a condition of page fault, and take the page frame here and move to here. But if the present bit is 0, then it directly take this page frame and move it to the TLB, so that next time when process need this page frame, there will be no requirement. But you ask very good question here again. That is, suppose the main memory had only available space of 3 page frame. Now, if all these are full and you need any other page which in the secondary memory, so how will you move this memory to here? Because it is already full. So how this happen? When this is moved, then there will be a thing happen, that is called page replacement. We have to replace some page from the main memory to the secondary memory in the exchange of one page frame from secondary memory. But how this happen? Which page will be moved? This will happen with a algorithm that is called page replacement algorithm. Page replacement algorithms. and there are two types of FIFO, first in first out. Which page come first in main memory will we go out first in the secondary memory. And second one is least recently used, in which page is the least least recently used page will go out of the memory. So how will these two algorithms work? Let's take an example. Suppose you have a 4 pages, okay. Your memory can consider, main memory can consider only 3 pages. Now suppose the main memory is currently now empty. So what will happen? If your process need pages in this sequence 0 1 2 0 1 3 0 3 1 2 1, so what will happen? So suppose your process need page 0, so what will happen? Page 0 miss because it is not present. So page 0 come, okay. Then what will happen? Page 1 again miss because it is not present, so it will happen 1 0. फिर 2 it again miss 2 1 0. Now what will happen? 0 it has a hit condition because it is already present. So what will happen? 2 1 0. Now 1 it will be hit, 2 1 0. Now 3 will be not present, okay, miss condition. So which page will be go first out of the box? The page which come first, because it will be a FIFO condition. So first page will be get out of the condition and new page 3 will become 3 2 1. Now will be in a new condition. Now again 0 is not present. So what will happen? Which page will we go out of the sequence? 1, okay, and it will be 0 3 2. Now 3 it will be hit. So what will happen? 0 3 2. Now 1 it will be miss. So what will happen? 1 come 0 3 because 2 is a first come in first out page. Now again require 2 is not present, again miss condition. So 2 will come 1 0. Now 1 hit because 1 is present, 2 1 0. Now if you calculate the hit rate, so what will be the hit rate? There will be only 4 times when the page is present which will be required by process. So only 4 and total time 11 into 100. So it will be 400 by 11% time page hit will happen. But there will be a better way by which we can optimize this condition. That is called least recently used. We see that least recently used has a better hit rate as compared to the FIFO condition. So let's see that. We take the same example. We do not change anything in the example. What will happen? 0 miss condition, 1 miss condition, 2 miss condition, 2 1 0. Now again 0 hit condition. Now it will be a least recently used. So this page has a mostly thus used. So it will become upward and this take them downward. Now you require 1 hit condition. It will move here 1 0 2. 3 miss condition, which is least recently used page 2. It will move up 3 1 0. Now you require 0 hit condition. 0 move here 0 3 1. 3 hit condition. Now 1 hit condition. It move here 1 3 0. Now 2. Now you have miss condition. 2 will come on the place of 0. 2 1 3. 1 hit condition. This move here 1 2 0. Now if we take here 1 2 3 4 5 6. 6 hit condition out of 11. So there will be a 600 by 11% of hit condition, which is better than the FIFO condition. So I hope now you understand what is page fault and how there are two algorithms used in page fault algorithm. Page fault basically is a condition that if main memory do not have a place to map all the pages to the page frame, then some of the pages are present in the secondary memory, that is called swap, and when the process need any page, first it check in the TLB, and if it present, it is called TLB hit. If it is not present, it go to the page table, check whether the page is present in the main memory or secondary memory. If it present in the main memory, the page will move to the TLB, so that next time it process need that page, it will be hit condition. If that page is not present in the main memory, then that condition is called page fault, and the page will be taken from the secondary memory and moved to the main memory. But how the pages are moved from the secondary memory to the main memory, this is with the help of page replacement algorithm. There are two algorithms, FIFO and least recently used. We give you the both the example FIFO and least recently used. I hope with this you will understand each and every point. We will meet in the next upcoming video. Till then, goodbye.